Unit 6, Day 3 video notes, negative exponents and scientific notation. Okay, I'm going to solve each of these problems two ways so that you can see each approach. And sometimes one approach will be easier or the other one might be easier. So we've got 5 over or divided by 5 to the power of negative 3. So this is the same thing as 5, like I say, divided by 5 to the power of negative 3. Well, again, this is the same thing as 5 divided by, and 5 to the power of negative 3 is 1 over 5 cubed. Okay. Now, how do we divide? We divide by multiplying by the reciprocal. So this is the same thing as 5 times 5 cubed, which is, of course, extend this a little bit. This is, of course, 5, sorry, fix that, times 5 times 5 times 5, which is 5 to the 4th power. Now let's take a look at the other approach. So the other approach says that if the bases are the same and we're multiplying, we add the exponents. Likewise, if the bases are the same and we're dividing, we're going to subtract the exponents. So here we have an exponent of 1 that's not seen. So we're now going to subtract 5 minus negative 3. And that is, of course, the same thing, 1 minus negative 3. That is, of course, the same thing as 1 plus 3, which equals 4. So we now have 5 to the 4th power. Next example. Oh, and let me box it. And of course, you can see I got the same answer with both approaches. Next example. Okay. B to the power of negative 1 raised to the power of negative 3. Well, B to the power of negative 1 is the same thing as 1 over B. And we'll take that and raise it to the power of negative 3. Now let's deal with the negative portion of this. That means the reciprocal. So I now have B raised to the 3rd power, and of course this is B cubed. Let's try the other approach. The other approach says that if we have an exponent raised to an exponent, we multiply the exponents. So I'm going to take this negative 1 and multiply it by the negative 3, which will, of course, give me a positive 3. So now I have B cubed. Again, both approaches gave me the same answer. If you can remember your rules of exponents, you can see that that actually is probably a simpler way to come to that answer. But either approach is valid. Okay, third example. I have 3 times x to the power of negative 1 and that whole quantity raised to the 2nd power. Well, first thing is, this is 3, and x to the power of negative 1 is 1 over x. So 3 times 1 over x, and then that whole thing is squared. Well, 3 times 1 over x is the same thing as 3 over x. And now again, I have that quantity squared. And when I square that, well, 3 squared is 9. Well, let me back up. 3 squared is, of course, 3 times 3. And x squared is x times x. And now that is 9 over x squared. Okay, let's try the other approach. The other approach, again, I have an exponent raised to an exponent. I'm going to multiply the exponents, but there's an important part here, and that is that there's this, which I need to square, but I also need to square the 3. It's sort of like distributing, but we don't use that terminology. So what do I have here? I have 3 squared times x to the power of, and 2 times negative 1 will give me negative 2. Well, now I need to deal with this negative, so now I've got 3 squared times 1 over x squared, which is of course the same, sorry, my squared disappeared, which is of course the same thing as 3 squared over x squared. And let's take it one more step. 3 squared is 9, and that's over x squared. Again, I got the same answer. Either approach is valid. Okay, now we're going to move on to another subject, scientific notation. So with scientific notation, it really is fairly simple, even though it seems to confuse people a lot. First key is that the decimal always goes in the same place in scientific notation. One number to the left of the decimal, all other numbers are to the right of the decimal. And then all of those are zeros. I don't have to worry about them. Oh, sorry, there's a 2 here. Let me put that 2 in. I'm putting in my non-zero digits. Now, if there was a 0 that was a placeholder and then there was a non-zero digit to the right of it, I'd need to include that 0. But as everything to the right of what I've written here are zeros, I don't need to include them. Now, I'm going to multiply times 10 to some power to make an adjustment. And I figure that out by counting how many places I've moved the decimal point. Now, of course, that decimal point, which is not written here, is located right there. Now, how many places have we moved it? We've moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I apologize. In fact, let me rewrite that number larger maybe so that we can see it, because I'm noticing that what I've written is off. It's a calibration issue. So let me rewrite this number. We have 5, 8, comma, 1, 2, 0, comma, 0, 0, 0, comma, 0, 0, 0. Hold on while I verify that I did it correctly. Okay, now let's count the moving the decimal point once more. I started off right here, all the way to the right, where the decimal that's not written is located, and then I count. 1 space, 2 spaces, 3, 4, 5, 6, 7, 8, 9, 10, to the point where my decimal is located here. So that means I have an exponent of 10, but there's one more thing that I need to address here, and that is this exponent positive or negative? And that's really very easy. When I look at this number, is this a number that is a large number, larger than 1, or is it a small number, smaller than 1? Well, this is larger than 1, so it's a positive exponent. So my answer, and I'm going to rewrite it just for sake of clarity, is 5.812 times 10 to the 10th power. Okay, now let's move down and try another example. Same thing, and I'm going to rewrite this again so that the counting will be easier. I'm going to make it larger. I'm going to put in my decimal. I'm not going to worry about the 0 to the left of the decimal. And then I've got how many zeros here? 6 of them there. 1, 2, 3, 6, and then 7, 2. Let me verify real quick that I wrote it correctly. Okay, so now, again, the decimal point always has one numeral to the left of it. Any other digits that I need to write are going to be to the right of it. And then that's times 10 to some power. Now, first of all, this number is a small number. It's smaller than 1. And so my exponent is going to be negative. And now let's count to see what it is. So starting here at the decimal point, I count 1, 2, 3, 4, 5, 6, 7 spaces to the new location of the decimal point. So my exponent, whoops, and I'm sorry, I left out my 10, so let me fix that. So this is times 10 to the power of negative, and that was 7 spaces, correct? 1, 2, 3, 4, 5, 6, 7, yes. So 7.2 times 10 to the power of negative 7. Okay, let's try some more examples here, but going the other direction. So this time they give it to us in scientific notation, and we need to expand it. So the first thing is, let's look at A here. It's times 10 to the power of 8. This is a positive exponent. We're creating a number that is larger than 1. So we will be moving our decimal point to the right, creating a large number. So let's take a look at where this is at. 4, 9, 5. And now my decimal point is right here. I need to move it 8 spaces. And I'm making a large number, so I'm going to go this way. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I need some zeros as placeholders now. So let's put in those zeros. Okay, next thing, where do my commas go? I have a comma every 3 zeros. So right there. So what is this number? We have 495 million. And then I need to put in all my zeros that are placeholders. What is that, million? 1,000? Yeah, 495 million. Okay, so let's look at the other example. This one has a negative exponent, meaning that I'm making a number that is small. Now, notice that all of these are larger than 0. When we're talking about a negative exponent, that doesn't make the number negative. That would require a negative sign out front. What we're talking about is that when the exponent is negative, we're creating a decimal, a fraction, a number that is somewhere between 0 and 1, not a number that is larger than 1. Or in the case of negative, of course, going the opposite direction. But we're not really going to concern ourselves with the negatives at the moment. we have a negative exponent. We're making a number that is somewhere between 1 and 0. We've got a decimal. So again, let me write this number. Oops, I better move it over because I'm making a smaller number. I'm going to move it over here so that I have room. 7, 6, 3. And now I need to move my decimal point from right here where I started 5 spaces in the direction that will make this number small. So 1, 2, 3, 4, 5. Now I need, my decimal point is here, and I need some zeros to fill in. A 0 here, a 0 here, a 0 here, and a 0 here. So my number now is 0.00000763. So let's see what that is. Tenths, hundredths, thousandths, hundred thousandths. Wait, let me make sure I do the tenths, hundredths, thousandths, hundred thousandths, millionths, 10 millionths, 100 millionths. 763 hundred millionths. And this is my answer.